Hey everyone, it's time to kick off another exciting edition of our DevOps Office Hours. It's June 21st, 2023. My name's Eric Osterman and I'll be your host. I'm the founder and CEO of Cloud Posse. We help teams conquer AWS using our rock-solid blueprints with Terraform. Whether you're starting from scratch or just not satisfied with your current setup, book a session with me directly by going to cloudposse.com/quiz. Answer a few quick questions, and we'll have a call to show you exactly what your future can look like. For those of you new to the call, the format's very informal. My goal is to get your questions answered. If you're curious about Cloud Posse or any of our open source tools and modules, this is a great place to ask. For those of us joining through the podcast or YouTube channel, you can join these sessions live by registering at cloudposse.com/office hours. Again, cloudposse.com/office hours. We host these calls every week. Our call today is recorded, and we'll be posting a recording of this session to our YouTube channel. So if you enjoy the content and want to support what we do over here, please hit those like and subscribe buttons. Just head over to youtube.com/cloudposse. Again, youtube.com/cloudposse. Also, if you find anything interesting today in the session, it's a great way to share it with your team afterwards. It's a full recording with the screen share and everything of what we talked about. So with that said, let's dive into the announcements. So here are some things that caught my attention this week that I'd share with everyone. First one is a simple little Ruby CLI to facilitate setting up the replication, the logical replication between two Postgres clusters. Helpful if you are working on a migration. Another tool was, or another announcement was from AWS. I'm a little bit confused by this. I haven't gone too far into it. I see we have Vlad here, who is the AWS translator for us. How is this different than the ability of connecting directly to EC2 instances, for example, with SSM?
I didn't really dive into this, so I don't know how to answer that, but I know this one allows you to also connect to stuff that is not an EC2 instance.
Oh,
so
okay. That's
stuff
probably
like databases or whatever other IPs are in your VPC. Agent still reverse engineered the implementation in the AWS console and released a thing for it. Give me a second to find it, but this wasn't interesting to me, so I didn't dive deeper into it. Sorry.
So I'll say why it was interesting to me, even though I don't think it still solves what we wanted to do. One of the challenges we have working with Terraform, managing resources inside of AWS, is that they're in a VPC. So we always have to deploy AWS Client VPN as part of a separate phase of the rollout, and whether that gets complicated pretty quickly. You have very large architecture, you don't want to have a whole bunch of client VPNs deployed for cost reasons. So we, connect over the transit gateway to get to the databases so we can provision users or manage the schemas in there. Similarly, if you are managing like EKS, which is sitting on private subnets, you need some way to connect to the Kubernetes endpoint for that. So I would love to see a way where one could have these kind of ephemeral, short-lived connections, opening up TCP ports on localhost like this does as part of the runtime of Terraform. Like imagine if you could do a Terraform apply and it creates a short-lived socket, a WebSocket, or not WebSocket, TCP socket to the Postgres database or to the Kubernetes API endpoint. And then that connection could be terminated at the end. That way you can still do a full Terraform build of resources. Alternative to that is, we run Terraform in AWS, like on EC2s or something through Spacelift or Terraform Cloud, or forthcoming is actually our GitHub Actions now. So we can do the same. Again, just more infrastructure to do something relatively simple.
What you want might be doable with this thing, but I'm not sure. Again, it wasn't.
No, I don't think it's doable out of the box, but this is kind of like this would be one of the right stepping stones to get there. maybe. All right. So next announcement is something that I confess, I don't know why I didn't notice it. So AWS Controllers for Kubernetes has been around for a while. I just remember it as an AWS Labs project and in a single repo. Looks like they've spun it off into its own org, and it's a total treasure trove of really awesome little operators to do cool things natively in Kubernetes that would facilitate, for example, Helm chart deployments of your full application stack in Kubernetes. Most importantly, what's interesting about this is, they have like an IAM controller, and also by breaking these out independently as separate controllers, I think that was really smart, because now the permissions of each controller can be restricted more easily. So has anybody been playing around with any of these controllers already?
I did, but very, very, very limited use cases, like just creating a couple of SKS queues and things like that.
Did you use the new model where they're all broken out into individual controllers?
Honestly, I've got no idea how that was deployed.
Understood. Cool. Well, something worth checking out. I think the IAM piece is really cool, especially because this way you can deploy services that are more self-contained. All right. Small announcement from GitHub. This was announced last September. It's been in a closed beta, I believe. Now this is generally available, so you can get larger runners managed by GitHub. Now, I don't believe these are free, even for open source projects. I think you have to pay. Here's something I stumbled across. I thought this is pretty cool. As we're building out our GitHub Actions for Atmos and Terraform, I thought, wouldn't it be cool if we could have an automatic graph? And we know there's the Terraform graphs, which are really ugly, and those are just static images. Well, what if we leverage the new Mermaid capabilities within Markdown instead? So I put me on a hunt to find an action that would do it. And sure enough, some smart person already came up with it. So, I don't have false solutions. A lot of these programmatic charts can be overwhelming or not as helpful, but I'm curious. This looks pretty interesting here. Input variables, output variables, what happens in between, logical kind of separations here. Of resources into groups. More complicated example. And while this is more complicated, I still think that for a newcomer probably coming to a project, it's much quicker to grok looking at this and then looking at the code afterwards to get an idea.
Related to that, I didn't want to bring it up because it's not actionable, but did you see the system initiative announcement? They went out of preview. I mean, private preview, but
I saw something about it. I forget where it was, on Hacker News or somewhere, but it didn't resonate with me because I guess it didn't hook me immediately. I don't know anything about it. I didn't get what it was. What is the system initiative?
It's the new DevOps infrastructure startup from the co-founder of Chef. They came out into private beta. Full disclosure, I had access to the preview, so I got to play around with it. It's super, super early, but they're doing some really fascinating things. Think kind of like Figma for DevOps, but a lot more powerful. I really love how they do a lot of things for you and how they made this really, really powerful. The example is if you connect to resources, they autofill some what would be Terraform parameters for you, which is, think of it, if you have a container running in Kubernetes and you want to give that container rights to a folder in S3, well, you have the container, the Docker image, you need the service account, service account mapping, you need the IAM role, the IAM role. all those annotations, which are basically just copy pasting IDs between things. And yeah, I quoted on the page and in the press release. And this just does it for you. Well, or will do it, because right now, if you play the video, they just have a couple of resources. Like, it's super, super early. But eliminating that annoyance to me is super awesome. On the compliance side, when you connect stuff or do actions, you can do qualifications, which are kind of like Lambda on Terraform, which allow you to like fill in more details, do checks, do policy checks, and things like that. And there, again, it's a super early product, cannot really use it right now, but
I know this dude. Who is this?
Yeah. I've been talking with them, and they've been like getting everything right. Like, whenever I ask them about, how is this gonna work for like thousands of resources, and how are you gonna actually make money? How are you gonna work against this particular? Like, they had answers for everything, and I am like super excited about this.
Cool, that's a good endorsement. So it's a open source core, at least.
That's the plan, but they still have some things to do before open sourcing it.
Okay, so it's not all up yet.
No, it's written in Rust, which is gonna get people excited, I guess.
Yeah. Okay, cool. And you said by the creators of Chef, but it's a totally separate organization, company. They've long left Chef, I take it?
Oh, yeah, it's Adam. I'm terrible with names.
Okay.
Adam something.
Gotcha. Cool. Anyone else have something to add to that, if you've been following it?
Adam Jacob.
Cool. All right. Next announcement. I think this is like the second or third one we brought up. Another command line CLI for kind of accessing LLMs to help you construct commands. So in this case, give me the command to list Git branches ordered by recency, and it spits out the command that you would need in order to do that. And another one here was a control tower one, basically tighter integration between control tower and SecurityHub with the ability for it to detect drift if certain controls that you've set at the control tower level are disabled. You can now remediate those automatically, I guess. Still really wish there was just native Terraform support for control tower. Be pretty sweet. And
is there an open issue on that? Just while you mention it, I feel like,
well,
why is that not the case? Do they not have any APIs to control?
Yeah, exactly. There's very, very minimal APIs in Control Tower, or
got it.
If any. I think there's like 1 or 2 APIs that it exposes, and it's been a slow progression.
Has anyone used Account Factory for in Control Tower for Terraform? That's something that we've been looking at using.
Yeah, we've done a pilot with it, and I think it solves a different use case than we were looking for. So with that, it's about really establishing baselines inside of accounts. And even then, it's all just run totally blind through a code build job, I believe, that runs Terraform, no ability to inspect the plan before apply, and so forth. Plus lots of manual setup to get it off the ground. And yeah, I don't know, it's just a different approach. You get automatic accounts created, of course, through it, but that's all done not with Terraform. That's done through a Lambda apparatus.
And then you hit every quota on the way down the tree. So, you hit all the limits about like their account factory. Yes, now you have an API interface to create accounts, but there's a bunch of hidden limits around the SCPs, around the accounts and the number of OUs you can have. And when they first released it, at least, it was a painful experience, and I just walked away from it.
That's good to know.
Anyone have dissenting opinions or other opinions?
No, not really. I would just say also take a look at the GitHub page and look at the issues, the open issues and the closed issues, and see if any of those would be a deal breaker for you. But yeah, depending on how big your org is, it's also a little bit expensive. So there's that to think about as well.
What was the thing? Did you have a link to the issues you were talking about for Control Tower?
1 second, let me see if I can find it.
I got it here. Linked it in the chat.
This is the Terraform module to help you set it up. Yeah, good call. Check out those, and if those are any deal breakers for you. All right. Last announcement, I was more or less skimming it. It was just an interesting, relatively recent post by someone who moved from Terraform to Pulumi for all the presumed benefits, and what some of the red flags were along the way, and that they ultimately pulled the plug on it and moved back to Terraform.
And it looks like he needs to be shown Atmos.
Clearly. Yeah. All right. With that, anyone else have any announcements that caught their attention this week?
You missed one of your announcements, number 3.
Oh, I did. Oh, yeah. Dang. Thank you for calling that one out. That's annoying. I spoke to someone this week. They had just finished their migration of consolidating all their domains into Google domains like end of last week or something. So now they're locked for 60 days, and then this announcement comes out. And yeah, we've been using Google domains too, and I really have liked it. The simple, no frills registrar, not trying to upsell me with every domain I buy. And now, if you are going to be upsold to Squarespace every time you buy a domain. So won't that be lovely? Yeah, it's impressive on the business side how disciplined Google is about shuttering things, not making enough money or being a distraction for them. But boy, does it suck when you're on the other side of that as a customer.
Does anyone here have any recommendations on what they're migrating off to?
Namespace or Namecheap.
Namecheap. I heard something about Spaceship, which is somewhat related to Namecheap, but I haven't figured out what Spaceship is versus a spaceship. Yeah. I think it's like the same company, but I haven't dug in too deep. I saw the Google Domains announcement, looking through the Twitter threads, the website builder. Okay.
Yeah, so as soon as I see this, then I say, oh, no, not interested. Every time I buy a domain, I don't want you telling me to build it with your builder. So I think that the least intrusive registrar, at least for a lot of people probably in this session, is going to be the Amazon Route 53 registrar.
But keep in mind, that's not AWS. So that may surprise a lot of people when they use it. But
oh, right,
you're not registered with AWS. You're registered with it's a French outfit, Gandhi.
Gandhi, yeah,
Gandhi.net.
Okay.
Yeah, and they used to be like 3 different registrars they were using on the back end, but I get the feeling that it may have been consolidated to that one outfit. I don't know. Has anybody seen where your domains actually are? Are they still using other registrars or just Gandy, or however it's said?
If you buy some international domains, they outsource it. I wasn't aware that there was a outsourcing for .com and other standardized domains.
Yeah, even .com, .io, there's a lot of them that come up Gandy. But I didn't know if they consolidated around it, because there were some announcements about who won the business and stuff like that on the back end.
Yeah, and Gandhi's been in the news this past week as well for some other reason. I don't know why, but you cleared up a lot of things for me though just by saying that, Mike. I'm embarrassed to say I've been a little bit confused by that too when I look at who is records for domains we bought there and why it said Gandhi or Gandy.
There have been some complaints about the French resolution process and French law not always being the what do they call it, the when you contest trademarks and namespace, that process legal term for negotiating stuff, the agreements, and when somebody has a protest over copyright. I'm missing the term right now.
A settlement.
DMCA.
Yeah, like settlement, like negotiation, one of those terms. Maybe they're a little aggressive in pulling the trigger for the complainant, and they're following French laws. Arbitration. Thank you.
Oh, arbitration. Yeah. Good. Okay.
I've never had a problem, but yeah, you want to know who actually owns your domain or is the registrar, and it's not AWS in many cases.
And I assume you're locked out from accessing it directly through Gandy?
I don't know. We consolidated away from them. So, but that it wasn't a decision on the basis of who owns it. It was that AWS does not have support for all the TLDs that we have. So obviously AWS would be a great place because you want to consolidate your domains, you want to run the org, you have one billing process, that's the dream. But there are quite a few TLDs that we have that just are not supported by AWS or Gandy. So we can't consolidate all of them in one place. Namecheap we can, but Gandy we can't. AWS we can't. Google couldn't do it. There's several domains that Google didn't support. So we didn't consolidate around Google. And so when this news broke on Google, we were saved that sadness.
I know over the years, a lot of our enterprise customers have just used something Mark Monitor, but I'm guessing that's not cheap. All right. Any other announcements? All right, let's do it. Q&A. First one, Hans, you had a question about introducing Terraform changes in a more temporally spaced way, propagating very slowly through some initial stages. Meanwhile, other changes can be applied more rapidly in those environments. And to me, that sounds maybe more about how the Terraform is constructed. If I'm reading between the lines, and I could be reading wrong, it sounds like a Terralith where you want to update sub-portions of an existing Terraform root module versus breaking the architecture down into lots of smaller root modules so that everything can be updated independently. Am I getting close, Hans?
We're not currently using Terraform, but we're looking into that. We currently use a mix of Ansible, Terraform, CDK, stuff like that. So we are focusing on it. Also looking at Atmos, using the modules, but even there I have that same question. Okay, say for example you use the VPC module and there are some changes in that. How are you going to make sure that some of the production environments still keep on the old version while some initial staging testing gets introduced to a new version?
Yeah, so there's a few ideas there, and I'll answer it as it relates to Atmos, and others can chime in on like what's done with TerraGrunt or other methods here. So the first thing is to think about deployment and release as separate things, and the terms are often overloaded within the industry. So in this case, here's like the component library, and we want to, like you say, keep the VPC behind maybe for a short time in production, but keep it current in dev, and try and keep probably staging not far behind. So the idea is that we want all environments to ultimately converge on the same version of the VPC.
Yeah,
but maybe not all at the same time. So when we make a change to the VPC, and I'm saying like we commit something into main, what we're saying is we want to deploy that change.
Yeah.
When we release it though, that is at a separate cadence. So we release it to dev, we release it to staging, we release it to production, and that's a deliberate action.
Yeah.
So for that, there's a few different ways it can be implemented. For Atmos, we do it one way. For people using like TerraGrunt or other Terraform tools, often what they do is they version pin the root module in every environment to what they want. But we don't do that. We don't do that for a specific reason. So what we do is when we plan the changes, we want to understand what the plan is of the affected changes of the VPC in every environment, so we know what the blast radius of the changes that we're doing across all environments, because maybe it will be a very disruptive change in production, but it might not be a disruptive change in dev. It might not be a disruptive a change in staging.
Makes sense.
So how we do that is we have an approval gate before applying the changes, before releasing the changes to an environment. This way, you can maybe do continuous delivery to dev. So when you merge into main, auto deploy it out to dev, but then queue up a release to staging, queue up a release to production behind an approval gate.
Yep.
And that's how we're thinking about it. Also, we have some, it's too soon to really announce, but we have some really exciting things coming very soon. We've actually already released it, but it's just not fully enough documented, so I don't want to promote it right now. But how to do all this with GitHub Actions. And right now, the recommended approach would be with Spacelift, which is another alternative.
Okay, and this also works with, for example, a mono repo where you have different teams working on it. So one approval flow is still pending while another thing is still going on. Okay.
Yeah. So what I'm showing you here is actually a mono repo for our infrastructure. Oops.
Yep.
And that mono repo has some Terraform components, and those components are all here. So each one can be revved independently of another.
Then you have the stack separately from this one, or you have the components together?
We recommend vendoring them into the monorepo. So if I go into like the S3 bucket and we look at the component file is referencing an upstream. However, we vendor that into the repository, so it's easy to understand how it all comes together. And if you need to, in a pinch, patch it, fork it, do whatever, you don't have to go through a huge process about getting it all upstream. You can just do it in your repository itself.
Yep. Okay. Makes sense.
Cool. All right. Any other questions we can get answered today?
I just had a sort of, I suppose it's a kind of follow up to that. Yeah, also it's my first time coming to the meeting. I've watched a few online, but yeah, glad to be here. So I had a question about, so at the minute we have sort of staged releases in terms of there'll be an end product or set of components that we're building, and that's the the end goal. But on the way there, there's a lot of dependencies. So one thing has to be created and it has to be up for a certain amount of time, and then several other things have to be provisioned in the meantime. And there's steps, so you can't just provision it all at the same time. So I suppose I wanted to ask about how, I suppose, best practices around that in general, and how it would work with Atmos, say.
Yeah, that's a trickier one to solve. If I understand it, you're doing kind of more complex releases to an environment that need to consist of multiple components updated in a particular order, perhaps?
Yeah, exactly. And so at the moment, we have quite a hacky solution to that, which is just sequential cookie cutter. Basically, it'll overwrite. So say if you imagine if main.tf contains like a Databricks deployment and then an EKS cluster and then also some EKS tooling, those can't all be provisioned at the same time. They have to happen in a particular order. And so the way we've tried to work around that is by, you have a template, and then you basically use Ginger templating to add those components, marking each one with a flag, basically, if it makes sense.
Yeah. So this is a tooling problem, or a limitation on how you use Terraform. It is similar to the kinds of problems that like Spinnaker were designed to solve. So how do you do complicated orchestrated releases across multiple environments? So in terms of solving this as a silver bullet, I can't give you a silver bullet answer, but I can give you two alternatives that we've used in different situations. So as it relates to standard CICD workflows like GitHub Actions, working with Terraform, with more complicated, with this kind of a scenario where you have an order of operations for your components, what we did is, well, first of all, the GitHub Actions are first decomposed. So there's a very easy way to run a plan. There's a very easy way to run and apply. And then for a given type of release strategy, we would create a workflow specific to that in GitHub Actions. So that workflow is watching for specific paths to change. And when those paths in your mono repo change, it always executes a standard workflow going through that sequence of events, first doing component A, which is a dependency of component B, which is a dependency of component C, and so forth. And it always goes through that order of operations. It's not intelligent in that, hey, if it didn't need to do B, it just skipped B and went straight to C. You still go through the formality of doing that with each one, except for there might be no changes. So that's a generic strategy that works with GitHub Actions. The more, arguably the more elegant approach, or the more like powerful approach, is when you're using a platform like Spacelift. Probably can be done with similar ones like M0, Scalar, Terraform Cloud, etc. But we're more particularly experienced with Spacelift. So we have a construct of a dependency. So when we do that, you can say that component C depends on component B depends on component A, such that when you modify component A, it automatically forces a plan of component B. In fact, you are not able to change component B until component A has successfully passed. And that's a concept of ordered dependencies supported by Spacelift natively. And if you're using our framework, if you're using Atmos, if you're using our Terraform modules and our strategy of doing things, you get that out of the box using Spacelift.
Great, thank you.
All right. any other questions we can get answered today?
I suppose if no one else has one, I have
Fire away.
a couple more. So I was just I'm new to Atmos, but I can't remember exactly how I came across it, and I really like the idea. I think I was at the time I was using TerraGrunt, and I ran into a lot of issues or just things that I found a bit aggravating about using it. And it seems like Atmos has it's a far more sane approach, especially when you start scaling, and so that's what we're doing at the moment. So I suppose my question is, if I'm pitching this to my team and the wider company as like a potential solution for us to move to, besides it being far more simple in terms of the YAML, defining this is my deployment, and you can just see it in one YAML file, the entire thing. You don't have to keep replicating the same format each time. What are the main draws that would because it requires some amount of relearning amongst it? What's the main sell, would you say?
So this is where giving a generic answer is sometimes not as effective, because the problems that led you here are the ones that we want to address, and that's why you should be using it. I can start with why we did it for ourselves, and the results of that we've been seeing for our customers as a result of doing that. So before we had Atmos, we were trying for a very long time to avoid a lot of extraneous tooling and just use Terraform as natively as possible. So we used makefiles, we used lots of environment variables, we used lots of var files, if I didn't say that already. We briefly tried TerraGrunt. The reason we went against TerraGrunt was we didn't like the precedent of code generation, or just that basically the projects that you were using with TerraGrunt were basically vendor locked into then using TerraGrunt in perpetuity. So that's what we didn't like about it. It kind of hurts because it's almost taking a contrarian position within the ecosystem, because lots of people using Terraform in advanced ways use TerraGrunt. So we wanted a way to have a promise of always using vanilla Terraform, so we could always break glass and do it any other way. And we also realized that the fundamental problem we were having was how to manage large-scale configuration. And that's a problem that wasn't well solved, I think, by other tools out there. So we solved the problem with configuration using this concept of a stack. And a stack is obviously an overloaded term, but the stack is how you define a bunch of different Terraform root modules that we call components all together. So the other problem we saw in the ecosystem was because it's really hard to decompose your projects into smaller root modules or components, people didn't. So you have these large components. You'll have a component that provisions your VPC, it provisions your EKS cluster, it provisions your database, and then a few months later, your Elasticsearch cluster, and a few months later, your Kafka cluster, and all of those things. And it works. It's nice on the one side because everything, Terraform figures out the graph and figures out the dependencies, but then it starts getting brittle. Your plans take 45 minutes to an hour to 2 hours to 3 hours. Your applies fail frequently and it doesn't work. So as we started solving one problem after the next, then we introduced new problems that we didn't know we had until we solved the other lower level problems. And that's why it's such a hard problem to explain, kind of why the tool is built the way it is. So jumping to the very end of the story, why you might want to adopt Atmos and what we have is you're buying into an ecosystem of how to, or like a framework of how to build infrastructure in a way that scales to a provable fashion, thousands and thousands of root modules deployed across, hundreds of accounts or environments. And that configuration is tersely defined in your configs, so it's manageable. We built the tool so with one command, you can break glass and you never have to touch it again. So maybe you're evaluating other options. There's Terramate and TerraGrunt and TerraSpace and probably others coming out there, but all of them lock you in long-term into how they built it. But when you follow this model, all we're doing is writing TF-var files. That's all we're doing under the hood, managing TF-var files. It's that you end up needing to, have ultimately different types of archetypes, so different types of S3 buckets and different types of EKS clusters and different types of databases. And you can't define that in pure Terraform without it being very non-dry. But when you use just this Atmos stacks, you're able to define archetypes. So here's what an archetype is of an S3 bucket for access logs, an archetype for an S3 bucket of these other things. So I'm being very hand wavy, and I could have just shown you kind of what I was talking about. But in like the catalog here, we go to an S3 bucket. So here's the baseline configuration that we want for every single Terraform bucket that we create. So as an organization, you can define that. And now this is a file inside of GitHub. And I don't know if you're using GitHub or not, but what's great about using GitHub is now you have code owners. So now you can have owners for different archetypes or for different areas of your infrastructure. So you can have code owners for managing S3 buckets. You can have code owners for EKS, or basically your subject matter experts. And then those subject matter experts create the patterns that you need for the other things you want developers to do. So there's a lot of upfront configuration that you do to establish well-defined patterns, but that's what you need in large-scale infrastructures. You don't, what I believe is that you need to set some standards because that's what makes it maintainable. So you have access to all the underlying variables that you need to set, but ultimately most people don't need to know that. And then when you define an archetype for logs, for CloudFront logs, you just need to know that you need to set the ACL for log delivery right, inherit all the defaults. And now anytime I import an S3 bucket for CloudFront logs, it's always configured the right way for my organization. And if the organization changes its policy on what the defaults are for a bucket, you can do that centrally. And then through drift detection, every single thing that leverages it can be updated. So I think this level of thought leadership is what's lacking from the entire Terraform ecosystem of tooling out there, is how to do the large scale infrastructures and how to think about the data model of your configuration for infrastructure.
But yeah, I think that's exactly the problem we're starting to run into. Is it was working fine, and now we're having to scale it, and it quickly becomes quite messy. I have a very unrelated question, and then I'll shut up. So I saw that earlier there was that sort of GPT CLI tool, and I was curious if anyone, well, firstly, had used it, what their experience was of it, and if they have, how it compares to Shell GPT, I think it's called, which is a lot more popular from what I can see.
Shell, yeah, I don't know, actually. That might be a fourth or fifth one we haven't announced yet. Shell GPT. Is this the one you were thinking of?
Yeah, that's the one.
Interesting. Oh yeah, 5,000 stars. I haven't seen this one yet. Have you been using this one?
I was a little bit. I have so many variations now. I have it in my menu bar. I have it just a regular. I have a particular app for it. Yeah, using it quite a bit.
Context, you got another way to do it.
Yeah.
Cool. So I know I was long-winded on that. We also have a few customers on the call. I don't know if anyone else has any opinions, active users of Atmos, on kind of like what the sell is for you on using it. Feel free to chime in.
Feel it was well stated.
All right, thank you. Cool. All right, more questions, anyone?
Sure, I asked one in the Slack channel. Just wondering if anyone has an experience with Galera cluster. I think I've seen it be promoted by MariaDB, and it looks fabulous, multi-master, multi-writer, something that AWS Aurora at one point seemed to be working towards, and then they deprecated. Just wondering if it really works and whether it has folks have positive or negative experience with it.
Wait, Jonathan, they deprecated the multi-master MySQL stuff in Aurora?
Yes, they did. Only available in version 1 or 2, and then version 3 doesn't have it. That was my reading of the docs, is that multi-writers is no longer supported.
Huh, I missed that. Vlad, do you know anything about that?
Not up to date, sorry.
All right, no worries.
I mean, it makes the Aurora architecture much more traditional. It makes it, much less auto magical.
Yeah.
And so as a result, you have to decide to vector certain queries to certain instances, not just, for optimization. You have to do it, and you have to make sure that queries vectored have either all the rights in one or none of the rights. It makes it you're responsible for it kind of architecture from a development perspective.
Just wanted to make put one thing on the table, make sure you are aware of, though, also the RDS proxy offering where it lets you do some of that vectoring.
Yes, I was looking at that as well.
Yeah. Yeah, and like what Jeremy White says, definitely used Galera back in the day when you still had to self-host databases, but haven't looked back since RDS. But I understand for large-scale use cases that you have. Honestly, it just makes me miss, or it's just, I wish, I wish Amazon would come out with something that did that more natively. I have a little bit of FOMO over, was it neon.tech? And I wish Amazon just bought them before somebody else does.
Right. Well, I thought that going back years that Aurora was the magical serverless whatever, but it never really seemed to come to pass. There are 14 varieties of Aurora, and only one limited version of them has any magic built into it.
Yeah. Yeah. It turns out that building databases is really hard.
Yeah. We really like the experience that we get with MongoDB Atlas. It's MongoDB, so it doesn't carry over into our relational database, but they really seem to have kind of cracked the code on how to run a nice database service. And we just, RDS and Aurora is still very much a plow your own field kind of experience.
Have you ever used or managed Elasticsearch?
No, we do use it. I'm not particularly familiar with it.
Again, this is old knowledge of Galera, but back in the day, just the similar notion of sizing your cluster right and stress testing it. I feel like I have to say it again. But if you already got stress tests, if you already know what breaks your database, is actually really the best stress test is to have the history of what makes things fall over. Then go ready, and at least assuming they haven't done anything too crazy in the last 5 years, then I would imagine it'd be worth trying something. It's an interesting tool set.
I just feel like there's so many other things than just the database. There's the backup process, the restore process, the monitoring process. Ultimately,
drills
for all your
drill it all.
replicas, and it's I think unless you have a team who owns it, I wouldn't want to.
Oh yeah, that's another thing to say. You definitely would need an engineer for it. Expect more than one engineer because it's going to have support.
Yeah.
I was curious if anyone's used geodesic with running it on DevPod or dev I don't know, is it DevPods or DevPod?
Oh,
It's essentially like the self-hosted version of Gitpod.
oh yeah. No,
Yeah, they kind of
we haven't
just
tried it
destroyed their
yet.
business.
Yeah, we wanted to, I want to offer that as a really easy, quick start for GDs to get up and running. I forget if I know we did a pilot with it at one point, but I don't know if what the current maintained state of that is. If there's no Git pod file here, but that, or like also doing supporting like Copilot. Are you using DevPod?
No, but I just listened to a podcast on it today, so I was quite. It just sounds like a great idea, because I was quite keen on Gitpod, but I didn't really want to pay. It wasn't kind of worth it to me. I've got a good, I don't know, like Docker and a good enough laptop. So, but yeah, if you can just self-host it, on anything, yeah, it definitely has a lot of appeal, especially if you're working with a lot of people and you can give them a general base template, and then they can sort of iterate on it by themselves. But you also have an underlying, thing which is shared of these are the tools that everyone who's working here in this capacity needs. So yeah, I'm going to try it out.
Andy Wortman says Aurora Multi-Master was actually only in Aurora 1 and didn't make it to Aurora 2 even. So, all right, good question. Any other questions we can answer today? Anything goes. Any questions? CICD, release engineering, Kubernetes, Terraform, AWS.
Well, I'll stick another one out there, just database related. SkySQL, essentially MariaDB as a service.
Have they cracked the multi-master?
I haven't really spent any time with them to know. I'm just gonna get, I'm just have been not 100% enthused with what we're seeing out of RDS, and I'm looking around to see if there's any other magic out there to consume.
And specifically something that's MySQL compatible?
Yeah, I mean, I wish we could make the Postgres jump, but that seems not not realistic, not timely.
Yeah. There's back in the day, MemSQL. I don't remember what happened with them. The Neon DB is by the founders of MemSQL. It looks like MemSQL is rebranded to Single Store. And this was based, I thought it was based at the time on MySQL's wire protocol. I don't know. Yep. Any other observations, questions, announcements?
Hi everyone. Sal over here. And this is also my first time joining this course, so thank you so much for having me. I actually just posted my question in the chat a while back, and this was just with regards to well, to sort of just reiterate my message, we have like an internal development platform, which is just a UI that allows a whole bunch of developers to provision infrastructure on a particular CSP. And what's linking this UI to the backend is basically harness pipelines. So effectively, once I submit a form through this UI, a pipeline runs, and the only thing this pipeline is doing is it's calling Terraform modules that we've built, for example, Cosmos DB, and provisioning those resources. So my question is, when it comes to running Terraform apply or standing up Cosmos DB purely from the module that's been built, what's the sort of best approach to actually executing that? So for example, does it make sense to download that module as a artifact, unpack it, and then run a Terraform apply, feeding in all the variables? Does it make sense to actually run a Terraform apply from an examples folder that's making a module call? But if that's the case, then how would we dynamically control the version, for example, that we would want to deploy for that module? So that's the kind of question I have.
So just a few things also to level set for everyone else. When you say harness, I think you mean like the continuous delivery solution?
Yes.
Harness?
Yes.
Okay.
Yeah.
And you've built your own internal custom paths for your company, so a way for consistent delivery of services, you said?
Yeah.
Okay, and that's
so there's a UI, there's the pipelines, and then we've got the backend sort of version control Terraform modules of a whole bunch of services. Yeah.
So, and then you mentioned something with examples that kind of confused me. Are you talking about CI now? How do you validate that you're...
So if you look at the a typical sort of structure of a Terraform module, quite like how you guys have for your modules, in the example folder, it's simply a means for someone to sort of know how to use that module that you've just built. But you can also, so I was thinking that you could also use that as a means to calling the module, stand up, for example, Cosmos DB. So rather than just downloading the module and unpacking it and running a Terraform apply, you just run Terraform apply from that directory, which sits within your examples folder. So I was just thinking of a couple of options of where exactly I want to be executing my Terraform commands from in order to get this module, i.e. this resource deployed when it's triggered from the front end.
Yeah, so, all right. I think I follow, but let me add a few things. So it sounds like what you might have today is a pretty mature strategy for how you do continuous delivery in general with harness. But the problem you're bringing up right now sounds like more of a configuration problem. How do you manage the configuration for these projects that are going to be using Terraform modules?
Yeah.
And okay. And that is kind of the problem we're solving when we say Atmos. And the gap I might see here, because I didn't hear it mentioned, is what you don't want is the configuration of what Terraform runs or whatever to be in harness. And where you do want that configuration is to be in VCS somewhere in your version control. So where are you defining this configuration for your applications that you deploy with Terraform that harness deploys?
Well, you say that. Our harness pipelines are actually configured to run Terraform apply. So harness is actually controlling the commands. And our modules are nothing exciting, but just Terraform modules. And they're all sitting in a mono repo. They've got versioning using a utility called Chaz Versio. So yeah, it's nothing fancy. It's just a pipeline. When the UI's form is submitted, it's basically making REST API calls. A whole bunch of variables get fed in through this pipeline. There's a pipeline per module. right? So let's just say someone wants to stand up Cosmos DB. The pipeline for Cosmos DB just runs, it goes and downloads the latest module version that's there in BCS, and it simply runs, or it's trying to run Terraform apply. Now, we are publishing our modules to a private registry, but we're not making the best use of that registry, right? We're still just checking out, the master branch and just running a Terraform apply of what the module's definition is, at the root directory. So if I want to give myself the ability to pick and choose that, okay, out of 7 versions of Cosmos DB that I've published to my private registry, I want to deploy version 4. How can I dynamically, or how can I actually have a means to do that, right?
So this is So I think that this is the problem that the tools like Atmos and TerraGrunt solve, which is how do you choose the versions to use for specific environments, and how do you manage that configuration? What it sounds like I'm hearing is you have something in between, like 100% infrastructure as code, and then something like a imperative, CLI-driven workflow. For example, let me compare like the difference between Terraform and the AWS CLI, just to set a comparison here. So with Terraform, I can create this project, and it has some Terraform files, and it has the resource, or it calls a module to bring up a cluster. Let's say I hard code some settings in the TF-var file with the size of my cluster and the number of nodes and so forth, and I run Terraform apply. Okay, so I did one thing manually, which was run Terraform apply. However, all the information, all the know-how of what should get deployed was entirely manifested inside of those files of that Terraform project. That's option 1. Option 2 is, imagine I was using the AWS CLI. I could just use the AWS CLI to bring up an EKS cluster. I specify a whole bunch of command line arguments, and I specify the size of the nodes and so forth. Maybe I get tired of doing that. I stick that in a shell script, but that shell script still is not tantamount or equivalent to the Terraform code. First, before I get into why this makes sense to your situation, does the contrast between what I'm doing with the CLI and the Terraform make sense?
Yeah.
Okay. Now, what I'm hearing is you have this kind of cool automation with how you can deploy Terraform, but all the knowledge, all those all the variables, so to say, are actually at runtime when you hit the REST API, or when you hit that API to call the Terraform. So now the question is, where do we store that configuration of how we hit the API to do what we're trying to do? And it's based on your solution, if that is the requirements, then it sounds like something very specific to how you're using Harness that we need to talk about. I'm going to argue that the problem is, help me understand why it works this way. Are you kind of trying to create a vending machine for internal teams to get resources?
Yeah, it's pretty much that. So it's a very typical or very basic internal development platform. So a developer who's working as part of a project, they want X number of resources. So they want a Cosmos DB, they want APIM, they want app service. So they select Cosmos DB, they put in a whole bunch of parameters, some for tags, and some that are very specific to Cosmos DB, like the size of the database or whatever it is, and they click submit. And what's happening is then that Harness pipeline, there is already a pre-built Harness pipeline, right? Which we're also version controlling because they're just YAML specifications, right? That pipeline gets triggered, right? Which is simply saying, I am hooked up, or I know that I'm hooked up to this module in this monorepo, like /Cosmos DB, and I need to run a Terraform apply with these variables, these dynamic variables that have been fed on runtime through Harness, or not even through Harness, but through the UI, like my internal development platform. And I'm just going to simply run a Terraform apply with all these input variables.
So is there, how does the destroy ultimately happen? How do you know that that environment is online, and how do you contain the sprawl? Is that something Harness supports out of the box and you're using native Harness functionality?
So yeah, I mean, currently we don't have a means for the internal development platform to destroy resources, only stand them up. So there's no Terraform destroy. That's one thing that we needed to address. But yeah, I think where I was really sort of scratching my head is that based upon what I described, when we reach to that stage where Harness knows that it needs to run Terraform apply, and the inputs are coming all the way from your UI because your user is giving those variables and feeding them in.
Yeah.
When the Terraform apply runs, right, it simply needs, we can either have a .tf file somewhere, right, and I make the module call for Cosmos DB in my private registry of version 1.0.0, right? So I can have a .tf file somewhere, and I'm making a module call of Cosmos DB, and effectively it's going to stand up my Cosmos DB because it's simply calling the module. Or the second option is that I know that my version or my versions of Cosmos DB is in my private registry. I'm going to curl that. I'm going to download it from, let's just say, Citizen, which is what we're using, right? I'm going to unpack it and then run a Terraform apply at the root directory, which is the equivalent of using a module resource in Terraform. So I was just, so between those two options, which is the only two options I could think of, unless there's a third.
Well, so I mean, we do this all the time. The equivalent, the business problem you are trying to solve is to make it easier for teams to provision the resources that they need for specific situations. And the way you're solving it is probably, well, that is some of the appeal with a tool like Harness. And that's probably what a lot of the demos are showing, that you could do it this way. But as antithetical, it's like it is the polar opposite of what we as a movement within Terraform are trying to do with GitOps. This is not GitOps. And I think there's a disconnect between platform engineering teams and more traditional DevOps in this space on what you should have. Ultimately, what I believe that you should be doing is at a fundamental level, there needs to be a document somewhere that represents the desired state for some environment. That is deployed through continuous delivery, your Harness, we use GitHub Actions, something like that to go out. Now, what is the UI for that? Well, there are two things. One is like our UI is going to be primitive. What we're saying the UI is a simple YAML file. And in that YAML file, if you wanted to add a new service, you can just add a few lines of code like this to a file. Now, maybe that's not appealing to your use case, but keep this in mind. This is just YAML. So instead, what I would be doing is I'd have something that is manipulating the YAML. So you always have a record of what is deployed everywhere. And you can therefore manipulate it, you can destroy it, you can do whatever you want with it. And how you manipulate this YAML, that could be via pull requests, that could be via programmatic commits and so forth. And this inspiration, like if you look at how Flux works, if you look at how Argo CD works, it's all this idea is that the system of record is a version control repository somewhere. And then the system like Harness or Argo or Flux, it's responsible for synchronizing what you have in that repository with your desired state in the platform of, you're choosing AWS or something like that, or Kubernetes.
Yeah. Okay.
So it's quite different approach. And I don't know if that's going to be appealing, but that's how I think it should be solved.
Yeah, no, I think that makes sense. I think that insight was was really good. So thank you for that. And I don't know if we've run over time, and apologies for anyone else that wanted to ask some questions.
Oh, that was good questions. Well, yeah, we are out of time. So thank you everyone for staying over today for office hours. I hope you enjoyed the show. We're going to be posting a recording of this session to our YouTube channel. If it's interesting and you want to share it with your team, that's a great way to spread the word. If you haven't subscribed to our YouTube channel, go to youtube.com/cloudposse to subscribe. If you're curious about working with Cloud Posse at any point in the future, just go to cloudposse.com/quiz. You'll book a session directly with me and treat it as a free consultation. Answer your questions. We also offer our podcast. It's a syndication of our office hours. So every one of these sessions is syndicated to our podcast at podcast.cloudposse.com. So you can listen to it however you listen to podcasts. Our newsletter is a syndication of the links that we post in office hours. So if you want to stay on top of the latest trends there, go to newsletter.cloudposse.com and subscribe. And finally, our Slack community at slack.cloudposse.com. This is our community. It's a very active community, heavily AWS, Terraform centric, GitHub Action centric, but it's a great place to get help from fellow peers, solve problems together. So thank you all. See you all next time.
Thank you.
Thank you.